Hi, good day everyone. So today we will be doing this past paper is January 2019. Number 10. And number 10 is your vectors and your matrices question. So let's begin one time. They said three matrices are as followed. We have P, which is minus 1, 2, 0, 5. Q is A and B. R is 11, 15. Now, before you even begin, what you should do is first off write the order of your matrix. Now your order of your matrix is the number of rows multiplied by the number of columns. Your number of rows is your horizontals, and your number of columns would be your verticals, right? So if we look at P, this is 1, 2, so it's 2 rows and 1, 2, 2 columns. So P is a 2 by 2 matrix. This one is 1, 2, 2 rows multiplied by 1 column, and R is the same thing, 2 rows multiplied by 1 column. Now they said using a calculation to support your answer, explain whether P is singular or a non-singular matrix. All right, so a singular matrix, the determinant of that matrix is equal to 0. And a non-singular matrix is when the determinant of that matrix is not equal to 0. So the formula that you're using to find determinant is, so the sign for determinant is let me put this in black, is this, and you put in the matrix here. So the determinant of P is equal to AD minus BC, where this is A, this is B, this is C, and this is D, right? So this will be equal to A by D is minus 1 by 5, minus 1 by 5, minus B, which is 2 by 0. So we see minus 1 by 5 is actually minus 5. Right, minus 0 is equal to minus 5. So because, just as working saying that because the determinant of P is not equal to 0, hence P is a non-singular matrix. And that would be the working on your answer for part 1. Now let's look at, and that's 2 marks, guys. Let's look at part 2. So first off, they said given that PQ is equals to R, I already wrote down what PQ and R is equal to. P is minus 1, 2, 0, 5. Q is A and B, and R is 11, 15. So they're telling you when you multiply P by Q, you're going to get R. Right, so first off, let's see if that's possible. We do this by saying this is a 2 by 2 matrix. This is a 2 by 1 matrix. We check to see if the number of columns and the number of columns in your first matrix and the number of rows in your second matrix is equal. They are, so we know that P and Q can be multiplied, and we know our resultant matrix would be this 2 by this 1, which is a 2 by 1 matrix, which is also the order of R, right? Now, we know that basically we have to make Q the subject, right? So if P by Q is equals to R, to make Q the subject, we carry across P. Now, the opposite of P multiplied by P, because the relationship between P and Q is multiplication, is divide by P. However, we know that in matrices there's nothing like division. We cannot divide matrices. So what they do is, instead of saying divide by matrices, we said R multiplied by the P inverse. Now let's check and make sure if this can be carried out or if we have to shift around the equation. We know that R, right? R is equal to a 2 by 1, right? And Q, let's put the Q on top here. No, not Q, sorry. P, right? P is equal to 2 by 2. If we try to multiply Q by, and even the inverse of P will still be a 2 by 2, right? If we try to multiply these two, right, our number of columns and number of columns in our first matrix and number of rows in our second matrix is not equal. So therefore, R cannot multiply by P inverse. So we have to readjust this where we have P inverse multiplied by R. And that is how you would find Q. Now, to find the inverse, it's a three-step process. However, we can just use the formula, right, where my inverse of P is equals to 1 over AD minus BC. And if we recognize AD minus BC is actually our determinant, right, multiply by your joint. And to find the joint of P would be to not to replace, to exchange the placement of A and D. So it'll be D and A, and we're going to multiply B by minus 1. So it's going to be minus 1 by B and minus 1 by C. And this here, everything here is how you would find your adjoint, not your adjoint, your inverse of P. Now, we already did this above, but let's put this. This is A, this is B, this is C, this is D, right? So we will just put it in the formula. P inverse is equals to 1 over A by D is minus 5, right? Minus 1 by 5 is minus 5. Minus B by C, we already see one of them is 0. So you just put minus 0, right? We leave that as is. Then let me erase this and make this a little bit better. It is D minus B, right? And minus C by E, right? So I'll have space, right? So we're going to exchange the D and A placement. So it's going to be 5 and then minus 2. Minus by B is minus 1 by 2 is minus 2. 0 has neither negative nor positive, so we just leave this as 0, and then we are replacing this placement with negative 1. Right, so now this becomes 1 over negative 5 multiplied by 5 minus 2, 0 minus 1. Right, so let's multiply this out. Okay, I'm probably writing a little too big. That is why I used up all the space. Right. Okay, so this would be 1 over minus 5 by 5. 5 could go into 5 one time, so it's minus 1. Then it will be positive, a minus and a minus and a plus, so it will be 2 over 5, 0. Anything multiplied by 0 is 0. And then minus 1 over 5 by minus 1 is 1 over 5. So this is your inverse of P. So now we are going to go on the side so we could have some space. Right, we have P inverse, so Q is equals to P inverse multiplied by R. We saw that P inverse is equal to, let's just check it, minus 1, 2 over 5, right, 0 and 1 over 5. 0 and 1 over 5. And R, if I am not incorrect, is equals to 11 and 15. Right, let's just make sure. Right, let's just make sure R is 11 and 15. So we're going to multiply the two. Remember, it's P inverse multiplied by R, okay? So it's minus 1, 2 over 5, 0, 1 over 5 by 11, 15. Right, so this is, it's always row by column, right? So let's just make sure this is a 2 by 2 matrix, this is a 2 by 1. These two are equal, so they can multiply, and your resultant would be a 2 by 1 matrix. So we have E11 and E21, which is, we have 2 rows and 1 column. So that's how I have element 1, 1, which is row 1 by column 1, and E21 is element row 2 by column 1. So we'll do this all one time, right? We have row 1 by column 1 is minus 1 multiplied by 11 plus 2 over 5 multiplied by 15, right? That is the first part. Your second part, which is E21, would be your second row by your first column. So it's 0 multiplied by 11 plus 1 over 5 multiplied by 15. Right, so this is, let's check it out, minus 1 by 11 is equals to minus 11. 2/5 of 15 is 5 going to 15 3 times, 2 3s are 6. So this is 6, right? So plus 6, right? And then we have 0 by 11 is 0, plus 1/5 of 15 is 3. Right, so let's just check this out. Minus 11 plus 6 is 6, 7, 8, 9, 10, 11. That's right. So as I was saying, minus 11 plus 6 is minus 5, right? And 0 plus 3 is 3. Now we know this is A and B, right? When we find the inverse, it's equal to Q, which is A on top, B on the bottom. So that means that A is equals to, going into the space, right? So this means that A is equals to negative 5 and B is equal to 3, right? And that would be the second part of the question. Right, now let's see if we can do the third part. State the reason why P multiplying P by Q is not possible. So as we know, Q, the order of the matrix Q was 2 multiplied by 1, and P was a 2 by 2, right? Now, we will have to say the number of columns in Q is equal to 1, and the number of rows in P is equal to 2. Therefore, they cannot multiply. So remember, as I was saying, right, if it's a 2 by 1, 2 multiplied by 1 and a 2 multiplied by 2, the number of columns in the first matrix and the number of columns in your number of rows in your second matrix must be equal. Because they are not equal, they cannot multiply, and that would be our answer for part 3. All right, that is 1 mark. Okay, so now we're going to do part B. You said ABC is a parallelogram. We know that the properties of a parallelogram are the opposite sides are parallel, and if we're talking in with respect to vectors, once they're going in the same direction, they are also equal. So OA, BC is a parallelogram. X is the midpoint of AB, Y is the midpoint of BC. OA is equal to R, so this is equals to R, and they said OA BC, right? Now, they said OC is equals to S. So OA meaning it's going from O to A, and OC is also going in this direction, so S. So that means if this is a parallelogram, we're going from O to A, then from C to B will also be R, and then from A to B will also be S. All right, then they said X is a midpoint of AB. Midpoint is the middle. So somewhere around where this orange dot is would be the midpoint of AB. Obviously, you guys will have your ruler, so you just measure the line AB, right? And the middle of AB would be X, because they said X is the midpoint, which means middle, right? And C is the midpoint of BC. So somewhere around here will also be Y, right? This looks a little bit, hold on. I'll do it in blue. It's somewhere more around this area here. I'm just estimating, guys. But when you have your ruler, you'll measure. The middle is where S and where Y, X and where Y is, right? Complete the diagram below to represent all the information given above, and that is it. You label where your vectors are. So this will be vector R, the opposite side. Once they go, you need to show the arrows, guys. It just tells the examiner that this vector is going from O to A, and that is R, and this vector is also going from C to B, and that is R. O to C would be S, and A to B would be S. If you put in it in the opposite direction, then you'll have to multiply by -1. And then if it's from B to C would be -R. But that is, we'll leave it as this. And this would be your 3 marks, right? Given that OX and OY is equals to K, open bracket, R plus S, where K is a constant, using the vector method, find the value of K. First off, we need to find out what is OX. Now, if we use our diagram, X is on the AB line, which is half. So AX would be half of S, right? And XB would also be half of S, right? So OX would be, your starting point is O, so it will be O to A, so OA plus AX. Right, so we know OA plus AX. OA is R plus AX. They're going in the same direction, so you don't really need to worry about multiplying it by -1. So OA is R, AS is a half S, and then we're going to put OY, right? You're using the same thing. OY would be equals to OC, so we're starting from O and ending at Y. Same thing here, guys. If we're going from C to R, CR would be a half Y, right? So we're going from OC plus C to R. That would be OC is S and C to R is a half R, not a half Y, guys. Made a mistake here. It's a half R, right? Because this CB is R. So C to Y is not, I put R here, C to Y, right? C to Y is a half of CB. So that's how I got CR is a half. CY is a half R. Right? So now they said when you add these two, so you're going to add R plus a half S plus S plus a half R. Let's add it as R plus a half R. Right? So you use this, plus a half S plus S. So R plus a half R, or same thing like if we're doing arithmetic. If we don't know there's a 1 in front of here, 1R plus a half R is 1.5 R plus 1S plus a half S is also 1.5 S, right? What they did here is they factored out what they have in common. What does 1.5 R and 1.5 S have in common? They have 1.5, open bracket, 1.5 by what will give you 1.5 R, 1.5 by R, and 1.5 by what would give you 1.5 S would be plus S, right? So therefore, they told you that OX plus OY is equals to KR plus S. If we compare it, we can see K is equals to 1.5. And that would be your answer for this question. And that is the end of this past paper, January 2019.